Welcome and welcome everyone. Today, we are going to completely master a huge topic in physics, waves. Now, I know why you are here. WAEC, JAMB, and NECO are just around the corner, and you know this topic is absolutely critical. So stick with me, and I promise, by the end of this session, you'll be ready for any wave question they can possibly throw at you. Let's get right into it. Okay. So, first things first, why are we focusing so much on waves? It's simple. This is what we call a banker topic. It's guaranteed. It shows up every single year in both the objective and the theory sections of WAEC, NECO, and JAMB. So, mastering this topic is your direct ticket to scoring some very high marks. And you can be sure that everything we cover today is exactly what you need to know. This is 100% aligned with the official WAEC and NECO syllabus. We're going to start from the basics, how waves are produced and how they travel. Then we'll cover all the important terms, the big one, the wave equation, its properties, and then the best part, we'll get our hands dirty, solving real past questions together. All right, let's build your foundation. We are going to start from the very beginning, just to make sure we are all on the same page and nobody gets left behind. So, what even is a wave? Well, in the simplest terms, it's a disturbance that transfers energy, not the actual stuff. Think about it like this. You drop a stone into a calm bucket of water. You see those ripples, right? Those are the waves. They move outwards, carrying energy across the water. But the water itself just bobs up and down. It doesn't travel with the wave. That right there is the key idea. Now, waves mostly come in two main flavors, and it all depends on how the particles move. First, you have transverse waves. I want you to imagine holding a rope and shaking it up and down. You see how the wave travels forward, but the rope itself is moving up and down. That movement is perpendicular to the direction the wave is going. Light waves are a perfect example. Then you have longitudinal waves. For this one, think of a slinky spring. If you push it, you'll see a compression move along it. The particles are moving back and forth, parallel to the direction the wave is going. That's exactly how sound travels. And this picture here shows you exactly what I'm talking about. Look at the top. That's your transverse wave, with the high points we call crests and the low points called troughs. Down below is the longitudinal wave. See those areas where the particles are all squeezed together? Those are compressions. And the parts where they are spread out, rarefactions. Let me tell you, you absolutely must be able to draw and label both of these for your exam. It's a very common question. Okay, to solve any problem, you have to speak the language of waves. So let's learn the key terms. Amplitude is just how high the wave goes from the middle. Wavelength, that Greek letter lambda, is the distance for one full wave. Frequency is how many waves pass by in 1 second, and the period is the time it takes for just one wave to pass. And finally, wave speed is just what it sounds like, how fast the whole disturbance is moving. Now, for the superstar of this topic, the most important formula you need to burn into your brain, the wave equation. It says that the velocity of a wave is equal to its frequency times its wavelength. V equals F lambda. This simple-looking equation connects the three most important things about a wave. You have to know this. Let's see how easy it is to use. Say a question tells you a wave has a frequency of 10 Hz and a wavelength of 2 meters. What's its speed? Well, first things first, you state your formula, V equals F lambda. Then, you just substitute the values you are given. V equals 10 times 2. And your answer is 20 meters per second. See? Simple as that. All right. Great job. Now that we have the fundamentals locked down, let's look at what happens when waves interact with their environment. We're going to cover their key properties, and then we'll look at the big, powerful general equation that describes any progressive wave. You know, every single wave, it doesn't matter if it's light, sound, or water waves, has 4 main tricks up his sleeve. They all do these 4 things: reflection, That's when they bounce off a surface like an echo. Refraction, that's when they bend as they enter a new material, like a straw looking bent in water. Diffraction is when they spread out after passing through a small gap. And interference is what happens when two waves meet and combine. Now, I want you to look at this general equation. I know, it looks a bit intimidating with all the letters and funny symbols, but please don't let it scare you. This equation is your secret weapon for WAEC and JAMB theory questions. Y is just the position, A is the amplitude, and those two symbols, K and that W, which we call omega, they are the keys that will unlock the wavelength and frequency for us, as you're about to see. Okay, theory time is over. Now for the most important part, stepping onto the exam battleground. We are going to apply everything we've just learned to solve real, actual past questions. This is where you really learn how to score those marks. Alright, let's kick things off with a classic question from the WAEC 2004 theory paper. Have a look. They give us a wave equation, y equals 5 sine 3x minus 4t. And from just this little equation, they want us to calculate the frequency, the period, and the speed of the wave. Now, before I show you how to do it, just take a second and think. How would you even start? The method is actually simple. It's all about comparing. You take the equation they gave you, and you write our standard form right below it. Y equals a sine kx minus omega t. Now, you just match them up. You can see that k must be 3 and the omega, must be 4. Once you have that, you just plug them into the formulae. Frequency is omega over 2 pi. Period is just 1 divided by the frequency. And the speed is simply omega divided by k. You see, all the answers were hiding inside the equation all along. Okay, next up, let's look at JAMB. Now, you know with JAMB, speed is everything. You have to be fast and accurate. So they give us another one of these wave equations, and they ask for just one specific thing, the angular frequency. This kind of question is a free gift, but only if you know exactly where to look. So read the question on the screen carefully. So here's the trick. The answer is literally staring you in the face. Angular frequency, omega, is always the number that is multiplying the t inside the bracket. In this equation, that number is 500. That's it. No calculation needed. You just pick it out. The answer is C, 500. The most common mistake here is people confuse omega with the normal frequency f and start dividing by 2 pi. Don't do that. And for our final challenge, let's take on a NECO question from 2009. Wait a minute. Does this look familiar? Of course it does. Once again, you are given the equation of a progressive wave, and this time they want the frequency. You should be seeing a pattern by now. The examiners for WAEC, JAMB, and NECO absolutely love setting this type of question. By now, you are a pro at this. So what do we do first? We compare. The term with a t in it is 200 pi t, so our omega is 200 pi. We know the formula that connects omega and frequency is omega equals 2 pi f. A quick rearrangement gives us f equals omega divided by 2 pi. So we have 200 pi divided by 2 pi. The pi's cancel out and we are left with 100 hertz. The correct answer is D. Fantastic work. We've crushed the theory and we've battled real exam questions. Now, to finish up, let's pack your final exam toolkit with a quick summary and some killer tips to take with you. Okay, get your phone ready. I want you to take a screenshot of this slide right now. Seriously, do it. This is your personal cheat sheet for waves. Every essential formula we've talked about is right here. Make sure you know every single one of them by heart. And before you go, let me give you 3 final tips to guarantee you get all the marks. Number 1, always watch your units. Examiners love to trick you with centimeters when you need meters. Number 2, if you ever feel stuck on a problem, draw a quick diagram. It really helps you see what's going on. And number 3, For theory questions, define your terms precisely and always try to give an example. I really want you to leave this lesson feeling confident. So remember this, you can absolutely do this. Putting in the work to really master this one topic is one of the smartest and fastest ways to boost your overall score in physics. If you found this lesson helpful, please do me a quick favor, like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also, make sure you visit examkp.com for thousands of free practice questions and answers. Let's smash these exams together.